In this video, we're going to explore the SQL default constraint. This constraint is a powerful tool that allows us to automatically set default values for columns in a table when no value is specified during data insertion. Join us as we discover how to use this feature to streamline your database operations and ensure data integrity. Let us start by understanding the basic concept of setting default values for columns. So, what exactly is the default constraint? The default constraint is used to provide a default value for a column when no value is specified during record insertion. This ensures that the column always has a value, even if it is not explicitly provided when adding new data to the table. Here is an example of how to implement this. In this create table statement, you can see that the in-stock column is of Boolean data type and has a default value of true. Similarly, the created date column is of date data type and has a default value of current date. So, whenever data is inserted into this table without specifying values for these two columns, the default values mentioned here will be automatically inserted. So, now let us see why we should use default constraints. There are several key benefits to using default values in your database schema. First, it improves time efficiency by eliminating the need to specify a value for every column during insert operations, making queries shorter and more efficient. Second, it ensures data integrity. Default constraints ensures columns always have meaningful values even when not explicitly provided, preventing null values where inappropriate. Third, it helps in standardization. It creates consistency across records by applying standard initial values for new entries when specific values are not provided. Fourth, it enables dynamic values. It supports functions like current date, current timestamp, or user to automatically populate fields with system-generated values. Now, let's explore the syntax for creating a table with default constraints. The basic syntax for creating a table with default constraints involves specifying the column name, its data type, and then using the keyword default followed by the default value you want to assign. In this generalized create table syntax, you can observe that the column 1 is of some data type and has a default value. Similarly, column 2 also has a default value. Here is an example of how we can create a users table. In this example, the active column is a Boolean data type with a default value of true. The join date column is of date data type with the default value of current date, and the last login column is of timestamp data type with the default value of current timestamp. Now, let us see how to add default constraint to existing tables. Here are the syntax for MySQL and MariaDB. Alter table, table name, alter column name, set default, default value. To remove a default value, use alter table, table name, alter column name, drop default. Now, here is the syntax for SQL Server, PostgreSQL, and SQLite. Alter table, table name, alter column name, set default, default value. To remove a default value, use alter table, table name, alter column name, drop default. Remember that adding a default constraint to an existing column only affects future records. Existing null or empty values in that column will remain unchanged. Here are some common default values by data type. For numeric types, integer has a default value of 0. Decimal has a default value of 0.00. Float has a default value of 0.0, and counter has a default value of autoincrement. For string types, char and varchar have a default value of empty string. Text has a default value of not applicable, which is a placeholder text. User ID has a default value of user in MySQL and MariaDB, and UUID/GUID has a default value of new ID in SQL Server. For date and time types, date has a default value of current date. Time has a default value of current time. Timestamp has a default value of current timestamp, and a future date can have a default value of current date plus 30. For Boolean and other types, Boolean can have a default value of false or true. Enum can have a default value of pending, which is a status value. JSON/JSONB can have a default value of empty object, and array can have a default value of empty array. Let us see a practical example of how to create a table called Employees with Default Constraints. In this table creation query, the employee ID is of integer data type and is the primary key. The first name and last name are of varchar data type and are not null. The email is of varchar data type and is unique. The department is of varchar data type with the default value of general. The salary is of decimal data type with the default value of 0.00. The hire date is of date data type with the default value of current date, and the active column is of Boolean data type with the default value of true. Now let us see how to insert data into this table without specifying all the columns. Here we are inserting data into the employees table with only the employee ID, first name, last name, and email specified. The remaining columns will take the default values specified during table creation. This table shows the inserted row with the default values for department, salary, hire date, and active columns. Now let us discuss some of the best practices for using default constraints. First is meaningful defaults. Choose default values that make logical sense for your data model. Use business-appropriate values rather than just technical placeholders. Consider what the natural state of a new record should be, and document why specific default values were chosen. Second is security considerations. Be careful with default values for sensitive data. Never use default passwords or sensitive identifiers. Consider using default null for sensitive fields to require explicit input, and use parameterized functions over hard-coded defaults where appropriate. Third is performance optimization. Default constraints can impact performance. Avoid computationally expensive default expressions. Be cautious with dynamic defaults that require lookups, and consider database-specific implementation details and limitations. Fourth is documentation and maintenance. Keep your schema clean and maintainable. Document all non-obvious default values in schema comments. Regularly review default values to ensure they remain appropriate, and consider using migration scripts when changing defaults in production. Implement default constraints thoughtfully to enhance your database design. If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.